Welcome, students of class 7. Today we will be discussing a chapter called Time and Motion. So if you open your textbook to page number 116, you'll be able to follow the class very easily. Before diving into the chapter, firstly, let's discuss a little bit about the title. Time. We are all aware of what time is, right? It is because of time we are able to differentiate the past, the present, and the future. Yesterday, today, and tomorrow. Motion. As you have got it in your lower classes, you must be probably very aware of what the meaning of it is. Motion is basically movement. That is, if an object is removed from its initial position to some new location, that changing of position we call as motion. Okay. Now the first topic that we have under the chapter is measurement of time in ancient times. That is, how do our ancestors measure time? Because obviously in those days they didn't have clocks, a watch to measure time, right? But yet they understood the importance of time very well. Because without time, there will be no coordination in working together. So how did they measure time in those days? Obviously through some natural events, that is like a day, solar day, or a month or a year. If they wanted to do some work together, they'll just say that we'll do this work today, or we will do that work tomorrow, we'll complete this work within a month, within a year, like that. Now, of course, to do simple work, just saying today, tomorrow, we will do that in a year or so, like that, it is fine. But to do something more complicated, we need to specify the exact moment of time, right? Suppose again, for example, if I say that your exam will be in the morning, that won't sound right, because even in the morning period also there are many hours in between. This is suppose the morning time period. Okay, we all know that there are many hours in between. So I will have to specify the exact moment in the morning at which the exam will start. Otherwise, a lot of confusion will be created. Some may come at the school at this hour, some may come at the school at this hour. A lot of disorder it will create. So that's why the need, the importance to measure time very accurately and precisely emerges. So over the course of generation, okay, as human civilization became more complicated and evolved, people created many tools, experimented with different ideas to measure time accurately. As you can see in the picture, these are various time measuring tools, right? But out of all this, the most convenient one is pendulum clock. It was invented in around 16th century. As you must be aware by just looking at the picture, a pendulum clock, why it is more convenient? Because if you look at this time measuring machine, this one requires a clear weather and the sun in the sky. And this one, every time you will have to remove or replace it with a new candle. But in case of a pendulum clock, you don't have all those problems. As a result, people accept that pendulum clock as the most or more superior clock compared to the other one. So like that is why in this video or in this chapter, we'll be specifically discussing about pendulum clock, because it is from pendulum clock modern watches and clocks are generated or branches off. So all right, as you can look at the slide, this one is also the pendulum clock, and you can see the interiors of the pendulum clock. They have many rings of different size inside them, right? We won't specifically be studying about the rings in this level. You will get all those in your higher studies, that is in mechanical engineering and all those sort. Today we'll specifically be studying about the pendulum, because it is because of the pendulum all these clocks are rotating in unison, that is in accordance to the oscillation of this pendulum. So all right, simple pendulum. What is a simple pendulum? I'll read out the definition first. A simple pendulum consists of a small metal ball. This is the metal ball, right? We will call that metal ball bobbed. suspended in a long thread from a rigid support. Suspended, here suspended means that it is not touching the ground, okay, it is hanging, it is in the air. So it is suspended by a long thread. This one is a long thread, right, from a rigid support, such that the bob, that is the metal ball, is free to swing back and forth. That means this one, it can go this side and then come back like that. So all right, now there are some terms that we need to get ourselves familiar with to understand the mechanics or physics of a simple pendulum. The first one that we have is length of the pendulum. So as the sentence suggests, length of the pendulum basically means the length of this, that is from the point where it's hanging and up till the metal ball. Next we have is mean of the bob. Mean of the bob means when the metal ball is not in motion, that is when they are at rest, this middle position, okay, that is what we call the mean position of the bob. Next, extreme position of the bob. That means when the metal ball is in motion, okay, in the extreme position, the farthest that it reaches, that is the extreme position of the bob, this side and even this side also. After that we have oscillation of the pendulum. Oscillation of pendulum means the motion of the pendulum, that is going to and fro. It means that suppose it is in motion, it will be going this side and then coming and then going, then coming back. This motion is what oscillation means. Next, at number 5 we have amplitude of the pendulum. Amplitude of the pendulum is a little similar with extreme positions of the bob. The difference is that in case of extreme position, it is just describing the position of the pendulum. But in case of amplitude, it means that how far or the farthest this metal ball can travel. Okay, so just remember, amplitude means how far, okay, how far it can travel, and extreme position means it is just describing the position at which they are at a certain point of time. Okay, so after these two, next we have is two important topics, that is time period of the pendulum and frequency of the pendulum. The first one that we have is time period of the pendulum. So what does the time period of the pendulum means? First I will read out the definitions. The time taken, okay, the time taken by the bob of a pendulum to complete one oscillation. To complete one oscillation is called the time period of the pendulum. It means that suppose here is the metal ball, okay, now if I push this metal ball with my hand towards this side, it will travel, right, it will be in motion, so it will travel this side and then come back this side, and as soon as it reach back here, we will say that at this point this metal ball have completed one oscillation. Okay, one oscillation. I'll repeat myself again. Suppose, okay, well, suppose this is the metal ball, so it will go this side and then come back, it will reach here and then back here. See, these 2 points are aligned, right? So at this moment we will call that the pendulum has completed one oscillation. Okay, now after time period, next we have is frequency of the pendulum. The number of oscillation made by a pendulum in 1 second, okay, is called its frequency. In earlier point it was one oscillation, the time taken by one oscillation. In this case it is in 1 second how many oscillation. Okay, suppose within a period of 1 second, here this pendulum is oscillating 2 times within 1 second, then we will call the frequency of the pendulum is 2. Okay, the value of the frequency will be 2. Or suppose if it is just oscillating 1 time in 1 second, then the frequency of the pendulum will be 1. Alright, now we come to this slide which shows the first numerical problem that you have. If you open your book to page number 124, you can see it in question number D, sub question 2. We will try to solve this one. First we will try to understand what the question is basically asking us. So I'll read out. The time period, here you look, the time period of a simple pendulum is 0.25 seconds. So now let's try to recall what a time period means. A time period means how much time one oscillation takes. Okay, one oscillation takes. That is, starting from this point, it will go this side and then go back and here. That is one oscillation. So how much time did it take? Here you look, 0.25 second. All right, now after this, next we have is calculate the frequency of the pendulum. Now we will try to recall the meaning of frequency also. Frequency means within 1 second. Okay, how many oscillation, how many oscillation. So that is what we have to find. We already know that the time taken for one oscillation is this much, that is 0.25 seconds. So how much will this oscillation complete within 1 second? All right, so let me clear the board and let's start solving. First we will write what is given in the question. So given time period of the simple pendulum, the time period is how much? It is 0.25 second. Now what are we supposed to find? We are supposed to find the frequency. Now we know. Why I said that we know? Because there is already a formula here. Frequency is equal to 1 divided by the time period, right? We will use this formula over here. So now we know frequency equal to 1 divided by time period. Now if you look at the question, time period is already given, that is 0.25 seconds. So we'll put that value over here, 1 divided by 0.25. So how many times 0.25 is equal to 1? That is 0.25 into x. X is what we have to find, equal to 1. So what will be the value of x here? It will be 4. Let's check. 0.25 into 4 is, you look here, 5 into 4 is how much? It is 20. So we'll write here 0. 2 will be the remainder. 4 2 is how much? It is 8. 8 plus 2 is 10. So 0 here, 1 will be remainder. 4 into 0 is how much? It is of course 0, but there is 1 remainder over here, so we will write 1. So now this value is 1, right? So that means 0.25 into 4 times is 1. So the answer is 4 oscillation. That means that in 1 second the pendulum completed 4 oscillation. Okay, frequency means in 1 second how many oscillation, right? Okay, so now next we have this another problem that is from your page number 118. If you open it to that page, you will be able to see. So firstly, we'll try to understand the question again. I'll read out. A simple pendulum takes 32 seconds to complete 20 oscillation. It means 20 oscillation. What is the time it takes? It takes 32 seconds to complete 20 oscillation. What is the time period of this pendulum? Now we have to find the time period. That is one oscillation. How much time it takes? That is what we will have to find out. 20 oscillation already given 32 seconds. So if 20 oscillation is 32 seconds, so now one oscillation will take how much time? All right. So first we will write what is given exactly in the question. We will write given. Okay. The time taken for how much? 20 oscillation. Okay, 20 oscillation is equal to 32 seconds. Now, time taken for one oscillation. Okay, time taken for one oscillation. One oscillation is the time period, right? It will be equal to what? We will have to divide this one with this one. Okay, 32 divided by 20. So now we'll try to do simple calculation over here. 32, 20. So of course it is 20 into 1, 20, 2 will come down, 1, 12 is smaller than 20, so we'll put point here, so 0. 20 into how many times is 120? Let's try 6. 20 into 6. 6 into 0 is 0. 6 into 2 is 12. So here see 120. 126. So the answer is 1.6 second. That means that one oscillation takes 1.6 seconds and 20 oscillation will take 32 seconds. Alright, some of you may have a little confusion regarding why did I use a division here. There is no formula like that, right? I'll try to make sense of it. First we will try to remember 1.6 seconds. Okay, so I'll clear the board and I'll write here 1.6 seconds. So now here it is given 20 oscillation takes 32 seconds. First we will write out this 20 individually. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 up to 20. Okay, suppose the up to here is 20. We can put numbering so that we don't get confused. This is 3, 4, 5, 6, 7. Here is 5, 6, 7, 8 up to 20. If you add all this, you will get the total will be 20. Now all this total, it takes how many times? It takes 32 seconds. All right, now we use division. Why? That is to find out how much this individual, okay, this one oscillation will take. So the answer that we got was 1.6 seconds, right? So we will write here 1.6 second. Here alone, this one also will be 1.6 second. This one also 1.6 second. This one also 1.6 second. This one also will get 1.6 second. Now if you add up all this 1.6 second, 1.6 second, 1.6 second together, the total you will get is 32 seconds. So here one oscillation, it takes 1.6 seconds, the time period. So that is why we use the division earlier. Okay, to find out how much time each of these individual is taking. Okay, all right, so then with this I will conclude the video. Thank you very much for watching.